Hello everyone. If you're watching this video, you missed our only meeting day for week 13. Let's go ahead and get to it. We have an assignment that's due Tuesday the 24th. It is to do with compound machines, our first order of business here. And then we've introduced the Catapult project, which is something we're going to be starting on next week. I hope that you can identify a compound machine in the real world and calculate its advantage. That's what the assignment is. You're going to begin planning for the Catapult project and identify required qualities in a good catapult. Let's get to it. So for compound machines, you have an assignment. It's assignment 22. It is due on Tuesday at midnight. What do you have to do? You have to find a compound machine in your house. Down here at the bottom, I give you some examples of things you could use. Scissors, pizza cutter, shovel, anything like that will count. Anything made of two or more simple machines. I'm going to use scissors as my example. First thing I ask you to do is either take a picture of your object, or if you don't have the means to do that, find one on the internet and put it in here. Next thing I ask you to do is list all the simple machines and their mechanical advantages. How do you find these formulas? Well, you can Google them, or remember, they're all listed in assignment number 21, which is right here, simple machines. So you can refer back to that and fill in those from there. Next, I ask you to figure out if the mechanical advantage or a distal one is what you get out of your compound machine. Think about it, just logically. Is your machine letting you do something easier by moving your hands farther than you would have to normally? Or alternatively, is it letting you do something faster or move something farther by applying more force? And then I want you to take some measurements and calculate roughly the mechanical advantage you're dealing with. If you have absolutely no way to measure things, you don't have a ruler, then you can go ahead and look up on the internet the mechanical advantages you would expect. Again, these are rough estimates, doesn't have to be exact. I'm just looking for you to demonstrate to me you understand the idea behind compound machines. Now, what is the idea? Well, the idea is very simple. You're going to find all the individual mechanical advantages. So let's say we find the wedge mechanical advantage, the screw, the lever, the wheel and axle, and the inclined plane. And then you simply multiply them all together. So you multiply all of these. It's the product of all five, and that gives you the total mechanical advantage. It's very, very common in things like staplers for the mechanical advantage of the lever part of it to be less than 1, and the mechanical advantage of some other part to be much greater than 1, and then they equal out to be some number a bit more than 1. Why? Well, you sometimes want a distal advantage to make it easier for you to move something, and then the mechanical advantage comes from somewhere else in the machine. So we combine them to actually get what we want out of the whole compound thing. All right, so that's compound machines. Now, I have some cool videos here for you. I suggest you watch those on your own. This is a catapult that was actually built at WJ. Isn't that neat? Look how big that thing is. Here we got a pumpkin chunking competition where they build giant machines to throw pumpkins, including catapults. This is all to get you in the mood and inspired for our project. So I gave you some popsicle sticks. You're going to be making catapults with them. Some rules. It's an individual project. You have to use the popsicle sticks as the primary material. However, for this project, I hear you loud and clear. Last time people told me that the main thing they wanted was to just use random stuff around their house. They've got stuff, they want me to let them use it. So, fine. You guys can use whatever you want in your catapult within reason, but the primary building material should be popsicle sticks. So don't build it out of Legos and then, that's a little much. Must use a crumpled up ball of paper or a note card as your ammunition. So no marbles, no rocks, nothing like that, please. May not be fired at anything living and should strive to reach the farthest distance possible. Now, I understand some of you don't have a way to measure accurately. That's okay. We can guesstimate. It's not the end of the world. I just want you to strive to shoot as far as you can. Here I give you a couple of sources you might want to check out. This one takes you through the history of catapults, which could be useful for your upcoming assignment. Hint, hint, nudge, nudge. And then I have a catapult simulator, which lets you actually see how far different settings will let you throw a ball using this catapult here. So there's all sorts of stuff to play with here, and you can see what works the best and play around with it. Have fun. So that is what I got. If all of that makes sense to you and compound machines are good, then you're all set. Otherwise, please shoot me an email. Set up a meeting with me. I've got time. I'm happy to meet with you Wednesday. I'm happy to meet with you after school. Let me know. And I hope you guys have a fantastic Thanksgiving. And I'll see you all in a week. Take it easy.